Class, welcome back to another exciting video on volume. This is our last video, and it has everything to do with volume of composite figures. If we remember back to chapter 10, we knew that composite figures were just multiple shapes kind of combined into one. Same thing happens with volume of composite figures. The only difference is we're in 3 dimensions, not 2. So, for a composite figure, we still have to recall that composite figures are made up of multiple shapes. These composite figures, well, they're comprised of various solids, including prisms, pyramids, cylinders, cones, and or spheres. Alright, basically all I'm saying is anything that we've calculated the volume for so far in this chapter, you can see again now with composite figures. So to find the volume of a composite figure, you need to find the volumes of the smaller solids and add or subtract them together, just like with the area of composite figures. In chapter 10, you had to find the areas of all the little pieces and then add or subtract. Now we're just finding the volumes. Alright, so this should not be too bad as long as we're feeling good with how to calculate volumes. So let's take a look at this first example at the bottom of page 22. Now, when I first look at this picture, I would actually say that this is just a trapezoidal prism, and you could calculate the area of this trapezoid and multiply it by the height to get the volume. But just for a good example of how to do these problems, I am going to split this up into a rectangular prism and a triangular prism. So I'm going to mark my shapes just like I did back in chapter 10. I'm going to mark my shapes with Roman numerals so I can kind of keep track of what I'm doing. So now I see I have shape 1, shape 2. Let's calculate the volume of shape 1 first. Well, how can we do that? Well, we know that this is a prism, so we're going to use capital B times H. I also know that I need to get capital B. So what I'm going to do is I'm going to sketch the base. Remember, I always ask us to sketch the base. And what I am going to use is I'm going to use this bottom piece right here. Okay? If we notice, right here along the top is 12. That means right here is 12. And here is 12. Okay? So now I know that this would be 12, and this length down here would be 5. So to get the area of the base, I just do 5 times 12, or capital B equals 60. Okay? Now that I have capital B, I'm ready to plug in. So the volume is equal to 60, because that's the area of the base, and then I multiply it by the height of the prism, which is 10, or 600. Not that bad. Let's see what happens when we switch to our next piece. Alright, again, this is a prism. There are 2 congruent parallel triangular bases. So it is a prism, and I'm going to use BH. Let me sketch the base. When I sketch the base, I'm going to use this front piece. I know it's kind of tricky because I'm switching it up. I'm using the front. Well, I know that I have a base of 12, and I have a height of 10. So I would say 1/2 times 12 times 10. When we calculate this, 1/2 of 12 is 6. 6 times 10. So again, the area of the base is 60. Now we plug into our formula. V equals 60 multiplied by. Be very careful here, guys. In the other shape, when I calculated the volume of the first piece, remember I used the bottom as the base. So the distance between the bottom and the top was 10. So the height that I used was 10. Now, what am I doing in this second figure? Now I'm using the front and the back. So now what is the distance between the front triangle and the back triangle? Well, that's this distance right here, or the 5. So the volume of this piece is 60 times 5, 300, and now I'm ready to go with the composite aspect. The composite basically just means we need to figure out, are we adding or are we subtracting? Well, I'm not taking away this figure from this figure. I'm actually combining them together. So I'm going to add my two pieces together. So I take my 600 from the volume of shape 1, and I add it to the 300, which was the volume of shape 2, and I get that the total volume is 900. And we notice we're in inches cubed. Okay? So again, very similarly to Chapter 10, we're just finding separate volumes and adding together. Let's try some more. Now, when we take a look at something like number 2, I know the picture's a little goofy. What they're really doing here is they're taking this bigger shape, what we would call a parallel, or actually this is just a, what did we got here? The base is a parallelogram. So this is just a parallelogram prism. So I would say that that shape is 1. And then we're taking away, or we're getting rid of this cylinder in the middle. So that's going to be my shape 2. Everything starts the same. I need to calculate the volume of each shape individually. So it's a prism, so I'm using BH. If I sketch, I notice that the base is 25 from down here, and then the height of the parallelogram is 25. So B is just equal to 25 times 25, or 625. Now that I have that, I need to plug it in. Well, we just calculated the base area was 625. Now we need the distance between the two bases, or what we call the height of the prism. The two bases are the front and the back, which means the height is 30 because that is the distance between. So when I come to the calculator, 625 times 30, I end up getting 18,750 for the volume of the giant figure, the big parallelogram prism. Okay, now I have to move on. For number 2, it's a cylinder, so I'm definitely going to use V equals pi r squared h. Now I just have to figure out what to plug where. Pi. Now my radius, just be careful. It looks like the diameter is 8, which means the radius is 4. So I'll plug in a 4 squared there. And then the height is the same as the prism. The height, or the distance between the two bases, was 30. So 30. Go to the calculator. Pi 4 squared 30. 480 pi. Alright. We're ready for the composite. Composite. In this case, hopefully you guys see and understand, I'm taking away the cylinder. I'm getting rid of it from the overall shape. So instead of adding shape 2 to shape 1, I'm going to subtract. I'm going to take it away. So this is going to be 18,750 minus 480 pi. That is perfect for an answer if you want to leave it exact, so we can just rewrite that. 50 minus 480 pi, and that would be in centimeters cubed. If you want, you can plug that into your calculator as well. 1780 or 18,750 minus 480 pi. Boom. 17,242.0 centimeters cubed if you want to round. Okay? The next picture, number 3, is going to be very similar to this, okay? The composite, hopefully we're seeing, I want to get rid of this cone. Alright, so if I need to get rid of the cone, that means when I come over to my composite calculation, I'm going to take away. I'm going to be using subtraction. Here, to get started though, I'm going to start by saying that my big shape turns out to be a square prism. I'm going to use as my shape 1, and then this cone that's in the middle is going to be my shape 2. We can say right now, we know the radius because the diameter is 18, we can say that r is going to be 9. Alright, so we're ready to go. Let's figure this out. Volume of shape 1, it's a prism, so capital B times h. When I sketch the base, both sides are 20, so this will be a real easy calculation. 20 times 20, or capital B, area of the base, is equal to 400. Now, the issue. I do not see a height. This 15, don't be tricked. This 15 is not a height. Why not? It's not perpendicular to the base. Okay, this is a slant height. We need the actual straight up and down height. And what we're going to do is we're going to use the cone to help us. Alright, if you notice, I can kind of extract this triangle, this right triangle, from the middle here. And I know that the slant height is 15. And well, the radius was 9. So how do I get h? Your friend and mine, Pythagorean theorem. 15 squared equals 9 squared plus h squared. 225 equals 81 plus h squared. 144 equals h squared. H equals 12. Awesome. We needed that not only for shape 1, but we're going to need that for shape 2. So we just killed 2 birds with 1 stone. When we come over here and get the volume now, we plug in that area of the base that we got before, the 400, and we multiply it by the 12. So the volume, 4,800 for the base, or sorry, for the volume of that square prism. Now we're ready for shape 2. We know it's a cone, so we're using V equals 1/3 pi r squared h. Let's plug in. We said the radius was 9. We said the height was 12. We go right to the calculator. Sorry guys, I just realized I was off the page. So, when we go to the calculator, 1/3 pi 9 squared times 12, 324 pi. V equals 324 pi for shape 2. Now that we have both of those volumes, we're ready to find the composite. Composite will be, we said, 1 minus 2. Why? Because we're getting rid of the cone from the square prism, so we have to take it away. So 4,800 minus 324 pi is more than okay if you want to leave it like that. So 4,800 minus 324 pi, and that would be in meters cubed. If you want, you could go ahead and type that in, minus 324 pi, and you could round it to 3,782.1 meters cubed. Both answers perfectly acceptable. Alright, I know this video is getting a little long. We're on to the last one. Here's what I would say, guys. If you're feeling good on this, go ahead and stop. I think at this point we've done enough that you probably have a good idea of how to calculate the composites. If you're still struggling, let's go through this last one together and then we'll call it a day. So, same thing as usual. Split it up. Shape 1, shape 2. This one looks like we have just about everything we need already, which is nice. All right, if we take a look at shape 1 first, we notice that this is a pyramid, so we know that we're going to use 1/3 BH. Let's figure out the base. Let's sketch it. Well, I know the measurements aren't there, but this base that I'm kind of highlighting right there is the exact same as the base down here. So we can use the measurements from the bottom base for the top base as well. So capital B equals 12 times 12, or capital B equals 144. Now when we plug in 144, so I forgot the 1/3. Sorry guys, let me redo that. V equals 1/3 144, and then notice the 18 is pointing to that perpendicular height, so we're good to plug that in. When we go to the calculator and we punch everything in, we should get a nice number. Let's see here. Perfect. Okay, the volume is 864 centimeters cubed. All right, shape 2. This one should be even easier. Oop, and I didn't mark that. Let me stay organized. This is shape 1. Here's shape 2. And it looks like we have a square prism, or maybe even a cube. Let's see. Capital B times H, because I know I have a prism. It's going to be the same exact base. I really didn't even have to do this, but let's do it. So the area of the base is 144. Now when we come and calculate 144, and then the height of the prism, just the prism, not both shapes, just the piece that we're looking at, is 12. So when we come to the calculator, we get, sorry, let me come down a little bit, V equals 1,728. Okay, we're ready to go. Composite. What do you guys think here? Hopefully we're recognizing we're not taking anything away from a shape. I'm taking the whole volume of shape 1 and I'm combining it or adding it to the volume of figure 2. So I will have to add these two values together. 864 plus 1728, go to the calculator, 864 plus 1728, boom, 2,592 centimeters cubed. All right, that's it. That is all we have for volume. Hopefully this lesson wasn't too bad, and it's just some more practice in remembering what you have to do, whether you're adding or subtracting. Okay, with the test coming up pretty soon, make sure that you're either talking to me or going to the MRC, seeking out the help that you need in order for you to succeed. Thanks for watching. Have a great day. Peace.